All right, so just like with the Unit 4, the fraction equations, we weren't allowed to divide by 0. We had to look at excluded values. Okay, not every solution worked. With radicals, the same thing. Not every solution will work. So we have false solutions. Okay, so with rationals, we looked at the excluded values, what made the denominator 0 once we solved it. With radicals, we're checking to make sure that the left side and the right side are equal. Okay, that the solution that we get actually works. Okay, we can't take the square root of negative numbers, so there's no imaginary solutions in these. Anytime we see a fractional exponent, remember we can turn it into a radical. Okay, so if you see a fractional exponent, convert to a radical. It's either going to be a 1/2 fraction, convert to a square root, or a 1/3 fraction, change it to a cube root. We're only working with square roots and cube roots. That's it. All right, so the first thing we want to do is be able to check to see if a solution actually works. Okay, so on number 1, they give us this equation. They want to know, does x equal 38? Is 38 the solution to this problem? So we can check by plugging 38 in for x and simplifying it. All right, so that's what we're going to do for this first one. So plug 38 in for x, and we just want to check, does the left side simplify to the right side? So 38 minus 2, does that equal 6? All right, well, 38 minus 2 is 36. Square root of 36 is 6. So yes, 6 does equal 6. So yes, 38 is the solution. Did you need a calculator for that? I don't know, maybe you did. Okay, if you don't know how to find the square root of 36, then yeah, you could throw out the calculator. All right, so then let's try B. Let's see, does x equal 4 to this solution, or to this equation? So we'll plug 4 in for x. So 1 plus the cube root of 4 minus 4, does that equal 2? Does the left side equal 2? All right, so we get 1 plus the cube root of 4 minus 4 is 0. And the cube root of 0 is 0. So does 1 plus 0 equal 2? No. Because 1 plus 0 is 1. And 1 doesn't equal 2. So that means that 4 is not the solution. All right, and then C, same thing. We're checking to see, does x equal -5? So 2 times the square root of -5 squared minus 9, does that equal 8? All right, so -5 squared is 25 minus 9. 25 minus 9 is 16. The square root of 16 is 4. 2 times 4 is 8. Yes, it is. So that's why it's important, if you're going to use calculators, you've got to be careful, especially with a negative like this. Okay, you want to put that in parentheses, because if you don't put this in the parentheses, -5 squared on most calculators will calculate it as -25 and positive 25. Because this says -5 times -5. Okay, so just be careful. All right, so that's how you check to see if a value, a solution actually works. Okay. So now, in general, when we're solving radical equations, we want to try to isolate the radical. Okay, if it's a square root or a cube root, we isolate it, meaning we move anything that's on the outside of the radical over to the other side of the equal sign. Then we square or cube both sides. That'll get rid of the radical. Then we just solve for x or whatever variable in the problem. And then we check to see if our solution actually works. There's 3 types of equations that you have to know how to solve. Right? So the first one says there's only one radical in the problem, and you don't have any variables on the outside. You just have constants, numbers on the outside. Okay, so your variable is only underneath the radical. All right, so this first case, we have to isolate the radical, so that means that plus 4 on the outside has to get moved over to the other side, so we're going to subtract 4 first. Okay, you got to make sure that you isolate this radical, get it by itself. Nothing can be on the outside, in front, or behind it. So 9 minus 4 is 5. All right, so step 1's done. We isolated the radical. Step 2, square or cube both sides. Since this is a square root, we're going to square both sides. Now try to get in the habit of the number, put it in parentheses, okay, and then square that. So the left side, when you square a square root, they cancel each other out. They're called inverse operations. So then the left side just becomes x minus 3. We got rid of the radical. Equals 5 squared is 25. Now we can just solve for x really easy, add 3 over, and so we get x equals 25. Sorry, 28. All right, so 28. So now this is where we go and check to see if our answer actually works. Okay, this is where it says, step 4, check for false solutions. So we're going to take this 28 and we're going to substitute it in for x and see, does the left side equal 9? 28 minus 3 plus 4. Does that equal 9? If it does, then 28 is the solution and we can keep it. If it doesn't, then we cross the answer, that 28 out, and we write no solution. All right, 28 minus 3 is 25, plus 4, square root of 25 is 5, plus 4, 5 plus 4 equals 9. So yes, 28 is the solution to the problem. Did you use a calculator? I don't know. Maybe some people did. The numbers aren't that big, so you probably don't really need one. All right, number 3. We have the radical. And so we got stuff on the outside of the radical that has to get moved over to the other side. So we're going to first subtract the 2 over. Subtract 2. So we get negative cube root x plus 1 equals 4 minus 2, 2. Now the negative in front is being multiplied to the radical, so we have to get rid of the negative. So we're going to divide both sides by negative 1 to get rid of the negative. So now we have the cube root of x plus 1 equals negative 2. Now the radical is isolated. Step 2 says to either square or cube both sides. Since we're working with cube roots, we're going to cube both sides. So we're going to raise both sides to the 3rd power. All right, so the cube root, cubing a cube root, they cancel each other out. And we just have x plus 1 on the left side. Negative 2 to the 3rd power simplifies to what? Negative 8, good. See, this is why we don't leave our answers with exponents, because we can simplify it. Some of you guys didn't do that on the quiz yesterday. Okay, you got to simplify when you can. All right, and then we can subtract the 1 over. X equals negative 9. All right, so now we want to go back and check to see, does it work? All right, so 2 minus the cube root of negative 9 plus 1, does that equal 4? All right, so 2 minus the cube root, negative 9 plus 1 is negative 8. 2 minus, what's the cube root of negative 8? Negative 2. 2 minus negative 2 is the same as 2 plus 2, which is 4. And 4 equals 4. So yes, negative 9 is the solution. All right, and then number 4, it's a fractional exponent, so what I would do, since it's to the half power, I would change it to the square root of x plus 4 instead of working with fractional exponents. Okay, plus 1 equals 0. All right, so now I'm going to isolate the radical by subtracting 1 over. Square root of x plus 4 equals 0 minus 1 is negative 1. Right, so it's isolated, so now we square both sides, square both sides. So the left side becomes x plus 4. The right side, negative 1 squared is what? No, it's positive 1. So this is right. It's really important. Negative 1 times negative 1 is positive 1. That's why we put parentheses. All right, so then we can subtract the 4 over. X equals negative 3. All right, so then we're going to check to see if it works. Now, the easiest one to plug into is, I would plug it into the one with the radical. It's the same thing. I mean, you can plug it into the original one, but it's the same thing. The half exponent is the same as the radical. Okay. All right, so checking, I'm going to do the square root of negative 3 plus 4 plus 1. Does that equal 0? All right, negative 3 plus 4 is 1. The square root of 1 plus 1, does that equal 0? No, because square root of 1 is 1, 1 plus 1 is 2, and 2 doesn't equal 0. So that means that negative 3 does not work, and our answer is no solution. No solution. All right. So that's equation type number 1, when there's just a variable underneath the radical and numbers on the outside. Okay, now equation type number 2, you have radicals on both sides. So what we're going to do is go ahead and square both sides or cube both sides right off the bat. These are probably the easiest of all three. These are the easiest ones. All right, so we could just square both sides. And it just cancels all the radicals and squares out, and we just have 2x plus 3 equals 3x minus 13 to solve. Okay, pretty easy. All right, so x equals 16. So when we're checking, all we're checking for, does the number underneath the radical equal the number underneath the radical on the other side? That's really all you have to check. So we're going to put 16 in for x here, plus 16 in for x here, and just see does the left side simplify to the right side. You don't have to square root or anything like that. All right, if your basic math is decent, you could probably do this in your head check. If not, you can calculate it. 2 times 16 is 32. 32 plus 3 is 35. Okay, so I get 35 underneath here. Now I check to see, do I get 35 under here? So 16 times 3, 48. 48 minus 13 is also 35. All right, and then number 6, we're going to cube both sides. Cube it. Get rid of the radicals, and we just get x equals 2x minus 6. I can subtract 2x over. Negative x equals negative 6. Divide by negative 1. X equals positive 6. All right, so now again, I'm just checking to make sure that the number underneath is the same on both sides. Okay, if I, 6 here and 6 there. All right, so if I plug 6 in here, there's nothing to do, it's just 6. If I plug 6 in here, 2 times 6 is 12. 12 minus 6 is 6. So 6 underneath helps. All right, so that's type 2. So the first two aren't too bad. It's type number 3 is the one that has the most work. All right, so I want you to see what makes it different from the other two. All right, so you get a radical. So you have your radical, you have a variable underneath and a variable on the outside. So it's inside and outside. Anytime you have a variable on the inside and variable on the outside, you're going to have to use factoring at some point in the problem, okay, towards the end to solve it. All right, so let's do this first one. So it's raised to the 1/3 power, so I'm going to convert it to a radical, so that would be a cube root. So it's the cube root of 4x. So the whole 4x is being raised to the 1/3 power, so the whole 4x goes underneath the radical. So let's just change it to a radical. Now, the radical's already isolated. There's nothing in front or added or subtracted to the radicals, so it's isolated. So now we'll cube both sides. So raise both sides to the 3rd power. So the left side just stays x to the 3rd. The right side, the cube and the cube root cancel, so we just get 4x. All right, so now we have to remember all the different things of factoring. So remember, you can't factor unless the equation's equal to 0. That's step 1. You have to have 0 on one side. So what I'm going to do is leave the x to the 3rd on the left side, because it has the bigger exponent. I'm going to subtract the 4x over. So I get 0 on the right side. So I get x to the 3rd minus 4x equals 0. Now I can factor it. So now we've got to remember all the different methods of factoring. First step, GCF. There is a GCF, we'll pull the x out. We're left with x squared minus 4. Now, x squared minus 4 can factor further. Good, it's a difference of squares, so it'll factor into x plus 2, x minus 2. Now it's factored all the way. Now we just set those factors equal to 0 and solve it. All right, so if we set x equal to 0, we get 0. If we set x plus 2 equal to 0, we get negative 2. And if we set x minus 2 equal to 0, we get x equals positive 2. All right, so we have 3 possible solutions to this problem. All right, so I'm just going to rewrite it down here because I don't have room up to the top just so I can show you. So the equation I'm checking is, I'm using the radical one. So you can do this, again, you should be able to do this checking in your head. Okay, the numbers, again, are not that big. So I'm going to check to see if 0 works. I'm going to put 0 here, and I'm plugging 0 here. So I just want to check, if I plug 0 here, will this side simplify to 0? Well, 4 times 0 is 0, the cube root of 0 is 0, yes. Okay, so 0 is one of the solutions. Now I check negative 2. So I put negative 2 here, negative 2 here. I want to see, will this side simplify to negative 2? 4 times negative 2 is negative 8. The cube root of negative 8 is negative 2. So yes, negative 2 works. I check the positive. 2 goes here, 2 goes here. I want to see, will this side simplify to 2? 4 times 2 is 8. The cube root of 8 is 2. So all 3 solutions work. All right, number 8. We have that fractional exponent, so I'm going to convert to a radical. X equals the square root of x plus 1, and then plus 5 on the outside. So I'm going to isolate the radical, so I'm going to subtract the 5 over. Now, x minus 5, you can't combine those together because they're unlike terms, so you're just going to write x minus 5. Now we're going to square both sides. Now this is where it's important you put parentheses around this binomial. Now the square and the square root are going to cancel each other out. Now with x minus 5 squared, since it's a binomial, you can't bring the exponent in, okay, and multiply exponents together. It's not x squared minus 25. You have to write out x minus 5 twice and then double distribute, FOIL, whatever you want to call it, to multiply it out. So you can write x minus 5, so you write it twice, equals, and then we just have x plus 1 because the square root cancels out. So this kind of a problem right here is probably the hardest type of problem on solving radicals. Okay, just because you're going to see it takes the most work. Okay, this is where most people mess up right here. They don't write it twice. They just bring this in and then call it good. You can't do that. You have to double distribute this. So you're going to take the x, distribute over, take the negative 5, distribute over, and you're going to combine like terms. You'll have a trinomial. Now, all this x plus 1, you'll move this over to the left side because you're going to have 0 on one side, because then you can factor. You'll have a trinomial that you'll factor. All right, so let's go ahead and double distribute this. So I'll distribute the x squared minus 5x. Then I'll distribute the negative 5. Negative 5x plus 25 equals, and then x plus 1. Now I can combine like terms in the middle. So that's x squared minus 10x plus 25 equals x plus 1. All right, again, because there's an x squared in this problem, this is where the factoring has to occur. But we can't factor unless it's equal to 0. So we're going to subtract the x over and subtract the 1 over. All right, so I get x squared minus 11x plus 24 equals 0. Now I have a trinomial, 3 terms, I can use the x method for factoring. All right, so 24 would go on top, negative 11 goes on the bottom. Two numbers that multiply to 24 but add to negative 11. Okay, it's going to be negative 8 and negative 3. All right, so then those become the factors, x minus 8, x minus 3. If I set those equal to 0 and solve it, I'm going to get x equals positive 8 and x equals positive 3. All right, so this is where we have to check now to see if they both work. Again, the math is not that difficult. Okay, I'm going to see if 8 works. I'm going to use this one right here. So I just converted to radical, so this is what I'm going to use. Just easier. So I'm going to try 8. 8 goes here. 8 goes here. So I'm going to see, will this side simplify to 8? So I'm putting 8 here and here. 8 plus 1 is 9. The square root of 9 is 3. 3 plus 5 is 8. So that means 8 works. Now I have to check 3. So 3 goes here, 3 goes here. I want to see, will this side simplify to 3? 3 plus 1 is 4. The square root of 4 is 2. 2 plus 5 is 7. 7 does not equal 3. So 3 cannot work. So the only solution is 8. All right, so 3 didn't work, only 8 worked. So 8's the only solution. All right, so let's do one more. Same idea as number 8. The radical's already isolated for you, so we'll just square both sides. So the left side just becomes x plus 4. The right side, since it's a binomial being squared, we have to write it twice. And then distribute, double distribute. All right, so then we can subtract the x over and subtract the 4 over. We want to keep x squared positive, so it's on the right side. We're leaving it on the right side. We're going to move everything from the left side over to the right side. All right, so we have a trinomial, 3 terms. We use x, 60 on top, negative 17 on the bottom. 2 numbers that multiply to 60, but add to negative 17. Okay, good. And they both have to be negative. So negative 12, negative 5. So then the factors are x minus 12, x minus 5. Set those equal to 0 and solve. We're going to get x equals 12, x equals 5. All right, so now what I want you to do is check to see if both solutions work. One of them works or none of them works. You figure it out. Okay, again, just plug it back in here. Ignore the squares. Okay, just plug it in here and here, see what works and what doesn't. Does 12 work? Yes, it does. Okay. So again, we can plug 12 here. 12 plus 4 is 16. The square root of 16 is 4. 12 minus 8 is also 4. Okay, so 12 works. If you make it work itself. Does 5 work? No. 5 plus 4 is 9. The square root of 9 is 3. 5 minus 8 is negative 3. Negative 3 and positive 3 are not the same. So 5 does not work. So the only solution is 12.